So here we will try to discuss about the inverse Laplace transform. So as we already familiar with these things, that whenever we are solving equation in the Laplace domain we can solve it easier, but to back to time domain, so how do we actually back to our time domain? So here we need to do Laplace transform. So instead of doing the Laplace transform, what we previously see that we can do it by integration. So instead of doing this, we can do it easily by partial fraction. So how do we do that? As from your secondary school or higher secondary, you might familiar with this term, how we actually do partial fraction. So we'll recap some things. So here I will recap one examples, so your understanding will get clear, and you can also get your understanding clear by uh, recapping your previous lesson, what you understand your secondary level. So here one Laplace domain signal xs is given. uh, it um, is a fraction number. So so to do it in the partial fraction manner, so we factorize into three terms. If we factorize our denominator term, so there is three terms, so we factorize it three terms. So what we need to do, we need to find a1, a2 and a3. So here I will try to give you a shortcut understanding how you get these terms clearly. So it only applies whenever your this fraction terms is not repeated. I'm saying again, this shortcut formula is applicable whenever this factor terms is not repeated. So it only once. See, here is s plus 4, s minus 1, everything is only one time. So to find it, what we'll do, so here there's three terms. So we will first consider the first term, s, this factor. So we will put s is equals to 0 and s is equals to 0 into this equation, and only we will not put s equals to 0 for the first term, as we are considering s is equals to 0 by considering the first term. So if we put everything in this s equals to 0, 2 times 0, s minus plus 4, so 0 plus 4, s minus 1, 0 minus 1. So here we get the first term. So to get the second term, we will consider the second factor, s plus 4 equals to 0. So here we will get s equals to minus 4. So here uh, uh, we also keep the s plus 4 undisturbed, and rest of the factor we will put s equals to minus 4. So if we put s equals to minus 4, we will get ultimately this minus 7 divided by 20s plus 4. Again, to get the third term, so we will consider the third factor, s minus 1 equals to 0. So here we get s equals to 1, and again we put this s equals to 1 value into our equation, and we'll get 3 divided by 5 plus s minus 1. So see, now our main function f of x of s actually factorize into this term. So this is the way we can partially fraction and bigger equations, right, or bigger function. So this shortcut we can only apply when this factor terms is not repeated. I am saying it again. So now what we'll do to inverse Laplace, as we already know from our table or from our formula that 1 by s, if time domain is 1 by s, in the Laplace domains we'll get u of t. If time domain is plus a, in the Laplace domain, whenever it's s plus a, in the time domain we'll get ud times e to the power minus at. So in this equation, see, 1 by 4 is a constant term, 7 divided by 20 is a constant term, 3 divided by 5 is also a constant term. So we have 1 by s, 1 by s plus 4 and 1 by s minus 1. So 1 by s is already ut. 1 by s plus 4, it will be u to the power minus 80 into ut. So here a is 4, so it will be minus, it will be minus 40 into ut, and 1 divided by s minus 1. So here see ut into e to the power t, because what we can write, s of minus 1. So in this manner, s value, a value is minus 1, so it becomes e to the power t. So in this way we can finally write our final time domain equation in this manner. See, in this way we can do easily Laplace transform. So after getting this equation, can't we solve it in our time domain? So in this way we can again return to our time domain from our Laplace domain.